Hi dear students, in this video we are going to study about equal vectors and vector operation. Here the definition, two vectors are equal if and only if their corresponding scalar components are equal, which means that u1 is equal to v1, here it is written, u1 is equal to v1 and u2 is equal to v2, it has to be. So with respect to this one, if we solve the question here, u and v are equal vectors, which means that a plus b, it should be equal to -1, and b minus a, actually 3 is equal to b, it has to be. So we have here two unknowns, a and b, they are the unknowns, and it's asking find a and b values. I'm going to write the system here. A plus b is equal to -1 and b minus a is equal to 3. Since the coefficients are different, I mean the signs are different, coefficients are same, I can add them side by side, which means that a and here minus a, we are going to simplify these two. So it's going to be equal to 2b, b plus b is equal to 2b. A and minus a, they simplify each other, and -1 plus 3, it's going to be equal to 2. It means that b is equal to 1, it's going to be, which is equal to 2 over 2. Okay, then if b is equal to 1, then we are going to find the a value. A plus b is equal to -1. We found that b is equal to 1, which is equal to -1. So a is equal to -1, a is equal to -2, it has to be. Here, the vector v is equal to 3, 7 has initial point 2 and 4, and the terminal point, it has terminal point. We don't know what is the terminal point, and it is asking to find the terminal point, but you know, in the previous videos, we named the terminal points with x2, y2, and the initial points with x1 and y1. So, here the vector, it should be equal to x2 minus x1 and v2 minus y2 minus y1, which is equal to y2 minus y1. Which is equal to here, x2 we don't know, we are going to find, and v vector is 3 and 7, this is this standard vector here, and x2 is equal to, we don't know, which is equal to x2 minus 1, x2 minus x1, which is equal to 2 here, and y2 minus 1, which is equal to y2 minus y1, it's equal to 4. So basically they are equal to x2 minus 2, it should be equal to 3, x2 minus 2, it should be equal to 3, and y2 minus 4, it should be equal to 7. Here we understand that x2 is equal to 5 and y2 is equal to 11. So the terminal point here we can name as t, but let's directly write 5 and 11, it has to be. So this is the answer of our question. Okay, now we are going to continue with the addition of vectors. Here, as you see, if you add two vectors u and v, you are adding also one by one corresponding components, which means that u1 and v1 you are going to add, u2 and v2 you are going to add. So u plus v, it's going to be u1 plus v1, and u2 plus v2, it has to be. So here, if you are adding them, it's going to be very simple. So that's why directly I want to add them, v2. Here, it's going to be equal to 1 plus -2, and here -2 plus 1, it has to be, which is equal to 1 plus -2, it's going to be equal to -1. -2 plus 1, it's going to be equal to -1. So u plus v, it should be equal to -1 and -1. Okay, the next one here, a is equal to -3 to b, a b vector is equal to 5 and -2. Find the coordinates of b. Here it's like the previous page question. This is the terminal point, this is the initial point. So x2 minus, if we say the coordinates x2 and y2 here it should be x1 and y1. And the AB, it should be equal to the vector AB, y2, x2 minus x1, x2 minus x1, and y2 minus y1, it has to be, which is equal to y2, we know that, we don't know, we know the y1, x2 we don't know, we know only x1. So x2 here, we are writing x2, x1 is equal to minus 3, comma, y2 we don't know, and y1 it's equal to 2. So y2 minus 2 it has to be. What is the value of AB? It's equal to 5 and minus 2. And we see here that x plus x2 plus 3, it should be equal to 5. And y2 minus 2, it should be equal to minus 2. Here x2, it should be equal to 5 minus 3, which is equal to 2. And y2, it's going to be equal to minus 2 plus 2, which is equal to 0. So the coordinate of B, it has to be 2 and 0. Okay. Here the properties. Quickly I'm going to tell this one here. Closure property means if the sum of any two vector in a plane is a vector. If it is a vector, again it is closure. And u plus v vector, v plus u vector, it can be written, this is commutative rule. Associative rule here, associative, this is associative rule. U plus v plus w, you can group differently and you are going to get the same result. 0 is the identity element, it is not affecting the operation, and with respect to identity element, you can find the sum of two elements. If it is giving you the identity element, it means that one is inverse of the other one in vectors also. So you are finding the additive inverse with minus u. We can simply say like this, if it is here 2 and 3 here, plus 0 and 0, again it's going to be equal to 2 and 3, and here 2 and 3 plus something it should be here, and the result it should be equal to 0 and 0. You know from the addition rule, that's why I'm not going to lose time to prove this one, but minus 2 and minus 3, so this is actually minus 2 and 3. If this is equal to u vector, then this is going to be, to completely like this is minus u vector, it has to be. So the sum is equal to 0. Okay, subtraction of vectors also is not difficult, like in the addition, and you are subtracting the corresponding components. If you are subtracting from u to v, what it should be, u1 minus v1 and u2 minus v2, it has to be. Here it says subtract v from u, means u minus v, it has to be. And the result it's going to be equal to u minus v, 2 minus 3, and 4 minus 2 it's going to be, which is equal to minus 1 and 2 it should be. Okay, here we have another vector kp and w vector, kp and w vector, and it is asking find, with respect to these givens, find w and kp and w minus kp, and you need to remember this one, p is the terminal point and k is the initial point, so you're going to subtract from p from the k, which is equal to, first the kp, it should be like this, minus 1 minus 3, minus 1 minus 3, and comma 2 minus 4, which is equal to minus 4 and minus 2. This is the kp. Okay, then we are going to here, we are going to Find now W plus KP. WK plus KP, W vector plus KP vector is equal to 1 plus 1 and minus 3, plus minus 4 and minus 2, which is equal to 1 plus minus 4, comma, minus 3 plus minus 2, which is equal to 1 minus 4, which is equal to minus 3, minus 3 minus 2, which is equal to minus 5, it's going to be. And the W minus KP, it's going to be homework for us. And this is the end of our video.